what we are going to do today is very much sharing some of the lessons that we've learned. And this is the subtitle of the session today. I mean, we are interested in data-driven research. And of course, when we started off early in the 2000s, we were doing the same as everyone around. Learning from Dartmouth, as I was visiting faculty at the time. Well, collating all the Medicare and Medicaid data in a single place and running code there and getting nice atlases and so on and so forth. So we were thinking that maybe, those centralized efforts were the money. But in reality, over the years, we realized that we needed, doing federated. And in our case, in particular, we are a country that is very much a federal country as yours. Is composed of 17 different regions. We name it autonomous communities, and then the actually the way that the system is designed is this way: is the entire planning, the entire financing, the entire provision of services at regional level, and there is a layer of coordination in the Federal Ministry of Health. So where the data is at regional level, even at more granular level. So in this context, of course, and then in Europe is very much, this federated approach to the world as well, to policy. There is a big difference in the case. I don't know if you're familiar with that, but in Europe, actually, there is a principle that is named political principle, that is the subsidiarity principle. That means that everything has to do with healthcare is in the nations, is in the member states, is not in the Commission. So there is a federation there as well. And actually, Europeans, we work along very well. And then when we do research, we do it federated. So federation is a need. There are maybe more technical reasons for that. Maybe next slide, Paco, please. You will listen to me saying Paco all the time. Paco is the nick for Francisco in Spanish. So well, and the questions, I mean, we are in the domain of health services and policy research. I assume that you are as well in this, very, very much in this domain. So, I mean, you will be singing my song very much, and we will be singing yours very much. You may agree with us that we do need very granular data, individual level data, and longitudinal data to respond properly to most of the questions. Frequently, we need this data to be sensitive, and then we need to be pseudonymized at source or pseudonymized on fly. We can talk about that if you wish. In some countries in Europe, in Spain in particular, we have to use pseudonymized data by law, because we need to track back the patients if needed for safety reasons, right? Well, very much. I mean, we are not addressing our efforts to a single source. We need multiple sources to respond to queries, the research queries. Some of them are public sources, maybe statistics. Canada statistics will produce, as Spain statistics produces a lot about socioeconomic and educational attainment and so on and so forth data, but also sensitive data that cannot be moved elsewhere. So this is another reason we need multiple sources to be linked and not to be moved elsewhere. We do include multiple sites in our research. Multiple sites may mean different providers. We name providers to hospitals, primary care centers. We don't name providers to the doctors and nurses, but we could also, name it for the purposes of research. A multiple site could be a doctor itself or a nurse itself. And many times, I don't know if it's your case, but in our case, our focus is the entire population, is the universe of potential observations. Even though it's true that we may need to use the minimization principle, as we do have this European regulation, General Data Protection Regulation, that one of the provisions is talking about minimization many times. A good response requires the entire population. And a final technical point, maybe it's not very usual in our case, but we may need computational partitioning as well because of the size of the need of, refreshment of the data, the need of, dividing the computation in different sites. This is not very frequent. Usually we do horizontal partitioning, not vertical partitioning. So same attributes for different people in different sites, but same attributes. And then usually this horizontal partitioning does not require much computation. But anyway, could be the case. So these are the reasons. It's not just that in the governance environment, the subject of our research is federated. Is also there are some technical reasons that require these to be made in a federated manner. And as I said, not just within the country, there is also federation, but also across member states in Europe and elsewhere, as you will see in some of the examples. Next slide, please, Paco. So the big challenge, I guess you are familiar with this, but just to show what is our scope, our view, and why. So in the end, the big challenge for the federation has been reproducible. Others would name it interoperable. And if we take the European interoperability framework that is actually was thought for public data, but is applicable to any type of data mobilization. When setting up a federation, a federated research, you need to cover these 4 layers plus one. The plus one is the governance of everything. An upper layer or a bottom layer, whatever you want to put it, or a side one, but a layer that governs the whole thing. And what elements we've learned out of our research, what elements are critical in the implementation and deployment of a federated research infrastructure. Infrastructure doesn't mean necessarily hardware, means all these elements here. Well, in terms of legal interoperability, I mean, within a country, most of the legal and most of the jurisdictions have the same, similar legal, let's say, restrictions. Same legislation for the country, same legislation for the regions in the country. When operating international, could be different. So you need to have this layer of legal interoperability. And then there are elements to address. Data visiting, so data doesn't move. What moves is the code. What moves is the technology. So what you are sharing is just the results. This is the data visiting principle. The needed to know in the minimization are these 2 principles that are very important in terms of the ethical interoperability. You have to demonstrate that you need this amount, this wealth of data to respond to the question legitimately, and then use just those elements, those variables, those attributes, the amount of data that you require to respond to the query is needed to know, and then we do use the minimal, of information as needed. Then we need to cover the idea that it's not easily identifiable. So data is pseudonymized. Usually we do research with pseudonymized data because we pursue, the update of the cohorts, or we pursue the inclusion of new attributes as data comes in. So we do need to do it pseudonymized. But we will have to assure the DPOs, the ethical people, that we are not able to re-identify the individuals tracking back, at least with natural, regular efforts, which our legislation is. Actually, there is a recent sentence of the European Court of Law Court of Justice, excuse me, saying that a pseudonymized data is personal data just if it's easily identifiable. So, and it is important to be able not to, not to identify, or showing that it's very difficult to identify. And then we have to be very careful and very, let's say, respectful with the disclosure policies in all our parties in the Federation. Maybe the case that some can disclose cells with less than 30 and then truncating a 30, but others may need truncating a 5. You have to be respectful enough to allow all to be joining this. So actually complying with the individual disclosure policies. So these are the elements that we've learned are needed in the legal interoperability box. In the organizational interoperability is what we name, they are named soft skills, but are so important. In the end, is the individuals participating, the nodes participating in the federation should have equitable access to anything. So you can overimpose, barriers of access. I'm referring here, if you need to do a huge investment to get your data translated into a common data model, for example, you are putting there a huge barrier. If you want them to be updating, so investing in updating the mapping to this common data model, is so, it's actually something that will jeopardize the participation. Then mutual trust. You have to build mutual trust. This is about transparency in all the process, parts of the process. You need them to be accepting the workflow, which is very, very, let's say, restrictive, I could say. We will show later. There is a need for co-creation loops from the design, and there will be opportunities along the process. And then, even though at the beginning, and this is a question of maturation of the federation, you can start with a master to worker architecture or topology. Someone is coordinating and the rest are responding to the queries, usually run the code, get the results, devolve the results. I will run the meta-analysis and produce the meta-analysis. This is the master to worker. It's much better to think that we can start this way because it's pedagogical. We want more people to be involved and engaged in the process, to learn more about that. But we have to allow room for P2P, which is peer-to-peer, those that have capacity to do something in the process instead of you as coordinator. It's better for the federation, gets more maturity and more sustainable in the future. So these are the elements that we found relevant in our work. In terms of semantic interoperability, there are elements that are very critical. You are researchers, guys, as we are, so this is quite natural for you. We do need a research protocol, right? But it's not just for us. It's for everyone, participating in the process. And I'm talking about the DPOs, the data protection officers. I'm talking about the data holders, those that are going to do the ETL process, the extraction of the data, the transformation of the data to your common data model. Those that are in charge of, deciding whether to participate or not. Those that are in the ethics committee, everyone around the project, and then the researchers. The common language, the common knowledge is in the research protocol. So we have to be sure that the research protocol is clear, transparent, and understandable for everyone around, not just the researchers. And a real important piece in that, and particularly important in terms of ethics, is the data management plan. A data management plan that should be covering all the aspects. And we can suggest to you, there is a European initiative, for sure there will be a similar one in Canada about open science that is fostered by the Commission, the European Commission, that is named Open IRE. that actually has different tools for open science. And they do have Argos. Argos is the data management plan template. I would suggest you to take a look at that, because it's the expression of every single thing around the federation and the management of the data. And this is a standard that you can use and you can reproduce in the future with others. So these two elements are very important for the common understanding of the project, for everyone that is around the project, not just the research team. Then, of course, the common data model, the semantics are here, and then you will listen this. I mean, we are part of Odyssey as well, even though we are advocating a bespoke common data modeling. We will show it to you, basically because it's more fitness for our purposes. We will be using OMOP as common data model if it's better, is fitting better our purposes. But in the end, what we found in the application of OMOP is that we need a bespoke one to respond most of our questions. So, well, but the common data model in the end, you have the semantics of it and the syntactics of this. And this is the key part of the rest. And this is where Paco will explain in the common data model builder. So I'm stopping here. And then the way you program. I mean, literate programming is important to get some semantic interoperability for those that are programming in the different nodes in the federation, or those that are not programming but want to know exactly or want to audit what you are exactly doing. This is where you will find the way to understand and to commit, and to commit in terms of improve. If you do literate programming, there are some examples there. So this is for semantic interoperability. And for technological interoperability, well, we advocate open source. We are open science guys. So this is our bias, if you wish. So we don't use any industrial solution that is not in the world of open science. I shouldn't be doing this because I'm one of the directors of the European Open Science Cloud, so I should be very, very careful with that. But no, it's in our DNA that we do open science from the beginning. So literate programming again here, and the use of containers to get all the stack. Paco will explain. Aspire, the other tool, is the container solution-wise thing that we use that can be actually deployed in secure processing environments. These are the lessons, guys. To get reproducibility in a federation, you need to cover them all. Next slide, please, Paco. Well, I think we can pass this because this is a natural flow in a federation to cover the legal and organizational interoperability when it comes to a master to worker. You see the flow of things. One is moving the code to someone that is one of the nodes. Two, running the code after extracting from the databases. And then three, devolving the outputs to the central node that has been in charge of developing everything and doing the meta-analysis, and then producing the publication for the rest. This is the master to worker. So if we had a peer-to-peer, one of those in yellow, in green, etc., should be doing the same as in the central place here. But this is the topology that I was referring to, and we are covering with this topology the legal and organizational interoperability. And when it comes to semantic and technological interoperability, in the next slide, we have to cover all this flow. This is the workflow that I was referring to, that everyone has to accept in the federation, from the research question on the left-hand side of the slide, PICO, T questions, the construction of the common data model, the construction of a synthetic data set that allows you to prepare the data quality assessment scripts and the analytical workflow. You see there some loops. These are the loops that I was referring to to the purplish container containing everything in, containing the deployment in the secure processor environment, etc., 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 till right-hand side, digital objects publication. And you see, this is the technological stack that we use. Our own creation, CDM builder for these steps, Aspire for these other steps, and then in the publication side, using R Markdown, Quarto, and publishing in Zenodo and GitHub. So everything is open source and is for you actually to test it. Next slide. Some examples. Yes, just crossing through. You have this slide deck at the end of the session, so don't worry. Go through it just to see more details. But the next slides will cover these 4 questions. Please, Paco, just go. Discovering throughput times in the attention to acute ischemic stroke. So this is process mining applied to the process of care in Aragon, Spain, Marche in Italy, Riga in Latvia, and Zagreb in Croatia. And then mining all the potential individuals suffering from a stroke with the suspicion of ischemic stroke within, the hospitalization process. So we are mining there using process mining in a federated way. This is one example. It's published. The references are at the end of the slide deck. Second example, changes in time to first treatment in breast cancer in March, April 2020, when Europe closed in the pandemic. Then the question was, those women that were diagnosed for breast cancer before, the days before, the weeks before, are suffering from some delay in the access to the treatments of breast cancer, whatever the treatment. The first treatment could be, chemotherapy, radiotherapy, surgery. And then comparing the 4 countries, Belgium, Marche, Wales, Aragon, Spain. And then you have here a sophisticated neural network, blah, blah. But the point is, we mobilize the universe of observations for breast cancer women in 4 countries exactly using this approach. Next slide, other example. This includes Ontario, by the way. So all the hospitals in Ontario, in Finland, in Sweden, in Spain, and in United Health in United States are being shown here. 30-day all-cost adjusted mortality, 180-day all-cost adjusted mortality, and some nice stuff, benchmarking the different hospitals and so on. I mean, again, the universe of hip fractures under surgery, very sophisticated, whatever, generalized additive mixed model, whatever, it doesn't matter. The universe of observation, 5 in this case, different countries using the same approach. And you can imagine here, the number of attributes that we consider in our adjustments. I mean, trust us, this is properly done. The point here is not if we've done it properly, because it's published already, peer-reviewed journals, big ones, whatever. The point is we can mobilize everything with this approach. And the last one, Paco is laughing all the time, is about the real-life effectiveness. This is a target trial with all the patients. All those receiving the vaccination, primal vaccination of COVID-19 in Brussels and Wallonie, the 2 of the 3 regions of Belgium, Finland, the whole country, Spain and Aragon, and see the differences actually in the transmission of the disease, the delay in the transmission of the disease as the endpoint of this target trial. So these are the examples. And then my last slide. These are the challenges. You've seen the challenges, you've perceived the challenges. Implementing a data visiting approach is heavy in code distribution. So you need to have the capacity. It's heavy in enrolling the data holders and the DPOs, because you need to enroll them to understand everything that you do. The achievement minimization needs very thorough elaboration of the CDM, the Common Data Model. In terms of organizational interoperability, building an interoperable federation requires, substitute the uneven capacities across the nodes. So there is an effort, a help desk, a graph user interface is needed. So you have to, at some point force them, engage them, very carefully. Otherwise, they will drop at the beginning. Synchronicity may be a challenge because, the different capacities make things difficult. But fortunately for us, usually our work is asynchronous, so we don't need much synchronicity. And the good thing is that we produce an output that help them to be engaged. As soon as they run the code, they get local results, node results, before submitting back. So they already have their own results, and they can use it for whatever they use. In terms of semantic, of course, there is a problem of using a bespoke CDM. If you need to change entities in the CDM, you need a different logic data model, then you need another common data model. So this is why we ended up with this tool, CDM Builder. In terms of semantics, also embedding data quality assessments, we are assuming that data at source is collected in a way that you can track back. It is not always the case. Particularly now in the European health data space, we can track till a point. The data holder has to be committed with providing information about data provenance, but we don't know. In terms of technical, this is why we use R and Python and GitHub and Synodo, because there is a strong dependence of the community of practice. And then there is a heavier programming effort because you need doing literate. So these are the elements. Thank you very much. I'm stopping here. Paco now will take over. I took a bit more of the time that Paco, so please excuse me for that.
I will try to anytime. Just a reminder of the process, because it is important in order to go for a more abstract research question or a more abstract hypothesis into the materialization that is a common data model. The common data model at the end of the day reflects the requirement of information in order to respond to the research question. That is important. And it has a high level of specification. Some checkpoints that may seem different from what you are used to see. One of these are the presence of a synthetic data set. Is in the process of asking or applying to access the data as is sensitive data, normally held by the healthcare system. There are times, there are delays that we can use in order to complete the development of our analysis. That is important to have to produce a synthetic data set arising from the specification of the common data model that is just prepped in order for the programmers to do the development of the analysis of the statistical analysis in order to be ready as soon as the data is accessible. And this is a very restrictive or a very systematic approach. The advantage of this, as Enrique said, is that it's reproducible, and it makes this easy to develop some sort of a factory over this approach. And that's the approach we have following our particular development, with some restrictions. We go for the secondary use of data. All our research questions are purpose guided, so we are not fishing. We have an hypothesis and we're trying to test it. We use a common data model as a cornerstone of the semantic and syntactic interoperability. All what we have to do in order to be reproducible and to gain trust in the different nodes or the different participants in any of the research projects need to follow the privacy and security by design. And in order to make it accessible, as Enrique commented, should be based in open source stack. Additionally, we want it to make it useful, not just for people with a mathematical, statistical background or with programming background. We want to make it useful for the clinical staff, for example, that is a part of the research effort. We want to make it really fast in order for us to prototype any research question that we have, and we want it to be ready to support both real-time analytics and advanced analytics if needed. So with this constraint of these guiding principles, we have developed ourselves three different tools. Two are software tools. That's the Common Data Model Builder and the Common Data Model Validator and Synthetic Forge. And the last one that is aspired is some sort of a framework or a template that includes a process and a template on how to introduce all the different pieces of the research project within a reproducible, secure processing environment, within a container that contains all the different technical layers or software solutions that you need in order to process the data, do the analysis, manage the data, and produce the expected results. I'm going to go very briefly, very fast over two of these tools, the Common Data Model Builder and the Common Data Validator, just to showcase a bit of what is the purpose and some features of these tools. Basically, the Common Data Model Builder is a wizard. It's an assistant that you use as a factory in order for you to have a standardized project, standardized research project. We took lessons from the development cycle and for the use of control version tools or control version platforms like GitHub, as Enrique mentioned. And what we did was configure a tool that helps you go through every step of the process in order to fully document a common data model specification that can be useful not just for the people promoting the research question, but also for the people that has to start the data, that has to transform the data, and has to provide access to the data. I will try to access the tool right now. This is direct, so I don't know if I will have any problem with that. But you have it accessible. You will have the link to it. So this is the landing page. It is currently translated in Spanish and in English, and it will show depending on the settings of your web browser. And the process is the process that is described here. So if you have already a project that already exists, you can load it here, and it will complete all the different things. And as you see, it's at first a very easy to use tool. It has a lot of tooltips and particular assistance, and it just guides you in the information required in order to specify in a standard way, in a standard manner, a good common data model. So these are some project metadata. You can add the authors, some of the format, some of the formatting decisions are in agreement with the publication settings of the Zenodo platform. That is the platform in Europe for the publication of research projects in open science. Okay, here is as easy as write whatever you want, and throughout the tool you have some conventions that you are not required to use, but you are promoted to use. You are encouraged to use. From there, you can name your cohort, and it asks you for the cohort definition. As you can see, the first information you introduce in the tool is very narrative. Okay, why? Because this is the document that is intended to be the cornerstone of the whole project in terms of the management of data. So it is a document not just for consumption of the people participating in the research project, but also for the consumption of the DPOs or of the health informatics people that has to understand what are your information requirements in order to complete your project. So you need some narrative and then some more specificity, okay? And the specificity comes in the way of templates or crosswalks. Okay. Then I'm not going to fully explain what is a crosswalk, but it's just a mapping for the definition of a variable that may require a particular catalog. For instance, an example that I can provide. In Spain, for a time, we did the codification of the conditions and procedure using ICD-9. We are now in ICD-10, but if we want to do a longitudinal project, we may have to have translations between the ICD-9 and ICD-10 code in order to define, for example, what is diabetes. This kind of crosswalks allows you to provide a very specific definition tied to a classification, a particular classification or a list of classifications to certain variables. You can use it both to set the inclusion and exclusion criteria and in each particular entity. And from here on, what you are defining is basically a relational database schema based on your entities, that is the equivalent of your tables and your variables, and you are asked to provide a lot of information. Okay, if I may, I will search for a particular one that we have already done, and you can see the one for the hip fracture. Okay, let me check this. I can go here. I can add the reference and load the. And here you see you have in a reproducible way. When you complete the information of the specification of the common data model builder, the common data model builder generates both the specification for humans and for the machine with the configuration file. Loading the configuration file loads all the information for the common data model. And this is just for you to have an example. You will see all the information that is required, for example, for the use case that Enrique showed before, comparing the hip fracture in the different countries. You have several, 3 in this case, entities. Each entity, I can open each entity with many variables, okay? For which of them you will have to provide certain information, all this information that you're seeing here, okay? Including, in the case the variable needs, the different catalogs with a definition of the variables suitable for each of the countries participating in the study. That's the way you bridge the semantic gap between the classification used, for example, in Canada or in Ontario and in Spain. The way you do it is with the domain knowledge of your counterpart participating in the country of origin of the data. So as you can see, it's a lot of detail for the specification. Some interesting things, apart from the standard classification, the format, etc., is that you are introducing here a legal requirement that is the requirement level of each of the variables. When we were talking about the minimization and the need to know, the need to know is related with a justification with a requirement of information for responding to the research question. And the minimization can be better expressed or better detailed here in the specification of the common data model in terms of the requirement level of the variable, if it's required, recommended, or optional. And you can also input additional relevant information that may configure the way the data is extracted, from where the data can be extracted, and provide examples or other comments. Okay. When you have everything specified, there is more that you can detail, and it is required for you to detail. Basically, the relationship between the entities, and if you want to do it, some validation rules or validation guidelines. that in this case are expressed as SQL queries. Everything done, you generate the common data model builder, and what you generate is a zip file, a compressed file, that contains the whole repository of the project. It contains everything, including the folder structure. So when I went here, this is the repository of the iconic project, the one you saw on hip fracture. And here you have everything. You have the documentation with a common data model, and I will go through here. You have a README file with some detail of the project and the instructions in how to run the container that contains all the analytical resources, okay? That is generated automatically via a GitHub action and is here. It updates with each release of the repository, and you have all the different documentation of the project. This structure, this folder structure, is the same for any project. So you have your inputs, your outputs, and your source, that is the code for analysis. And the advantage or the benefit to using the common data model builder is that you specify once, and the common data builder do all the heavy lifting. In terms of you are providing the knowledge, you are providing the domain knowledge, and the common data model builder is producing for example, this is silly, but it's producing the entity relationship diagram of the logical schema. It's producing some synthetic data set with an informative distributions, but with the detailed specification that you have put in the common data model for each of the entities that you have defined. So you have already a support for your development. It's producing automatically also some of the analysis. Basically, the analysis that check the compliance of the input data with the specification of the common data model that you have here, and you can audit. It's producing automatically the data quality analysis scripts. So there is two different data quality analysis. The first data quality analysis of the inputs, so the raw inputs, and then the one that is going through the validation rules that you have established and producing a report on the validation routes. Okay, this is a generation of the report, and here is the place, the folder in which you put your analysis, the statistical analysis you produce on top of the definition of the common data model. So you have the entire project. And what you have to do after you have your common data model specification is just go to the next step. That is, let me check the slides. Go to the next step is bottling up or containing it in a container solution for which we have Aspire. That is just a template of a Docker container that you fill out with your dependencies for your analysis. So the packages, libraries, or whatever you need in order to complete your analysis, your statistical analysis, and the structure of the project, the entire structure of the project. And what Aspire provides you is with a systematic process, again, somehow automated, in which you get the project structure, you add your environment, you declare your environment, you add your Docker file, you can modify the environment and the Docker file, add the logo, and set the time zone. This is important because when you are doing international research, time zone management can be a pain in the ass. And then you can automate the production of the container solution just using the GitHub actions. And from there, you have your project completely automatized. Another advantage is that you have a single point of truth. So everyone in the project knows that the repository is a place of reference to find anything, any documentation, any information, and any code that is required to conduct the analysis. okay? And with that, you fulfill the cycle and close the gap and make possible to do federated analysis in any environment with almost any capability. It's a little bit more complex in the technical way because you have to take into consideration the capabilities and both in terms of hardware and software and knowledge for each of the node participating, but it's as complex or as simple as that. With this, you have the whole infrastructure mounted, ready to work.